So welcome to the presentation. Maybe something different from other presentations, right? We're talking about Internet of Things here. The talk for today is an introduction to a platform, an IoT platform called FogLAMP, which is something that, well, you're going to learn what it is in a minute. Before we start, I'd like to know if is anybody being involved or you are currently involved in Internet of Things projects? Now? Nobody? One person? Two? Well, you are involved in everything. But yes. Okay. And I guess that maybe more people will be involved in Internet of Things in the future. Just a guess. I may be wrong. My name is Ivan Zoratti. I'm the Chief Product Officer for Dianomic Systems. So the first thing to say, just in 30 seconds, is who we are. So Dianomic is a company, is a startup from the Bay Area, from the usual Silicon Valley world. It's just a one-year-old startup. Dianomic comes from the Greek, which means distributed or distribution. So kind of a nice name, but more important than everything else, the domain was free, just $10 and ready to go. So that's what we've done. And the focus is simplify IoT data. What does that mean? Well, you'll see again in a few minutes, because in IoT, things seem to be similar to the rest of IT. Actually, it's not that similar to IT. It's a combination of IT and OT, of information technology and operations. And that is a big, big difference. But you see, or you may agree or disagree with me, and I'm happy to hear from you, of course, not only during the talk, but even later. So today, the agenda for this talk is around, first of all, what is IoT? What is IIoT? What is fog computing? Maybe terms that you may have already heard of or not, we'll see. What is FogLAMP? Some of the use cases, the architecture. If I can, a short demo, and that's why I was just messing here with some of the stuff that I brought. And what are the next steps for FogLAMP? So everybody knows what IoT means, I think, I hope, Internet of Things. So just to make it super simple, Internet is usually used by human beings, and now we are saying, okay, why don't we add also things that are all connected together into this big bucket that is the Internet. And that is great, and you may know about that by using your Fitbit or having your thermostat or other things at home that are connected to the Internet. That is great, and definitely consumer IoT is really, really important. I mean, it is really the way things will explode. But the real business and the real challenge in something called IIoT, meaning Industrial Internet of Things, where things are not consumer-based, but are more business-based. So we are talking about connectivity and interaction of things that are in vehicles, like cars or trucks, lorries, or in cities, so smart buildings, smart cities, smart roads, everything is smart, but just to say connected stuff that interacts together with other things. So all these things that are not related to what we wear or what we have at home, but still extremely, extremely important. And above all, also very much, let's say, from a business point of view, expensive, and they must provide a service all time. Because if you may be disappointed if your Fitbit doesn't work for a few minutes. You may be even more disappointed if the electric grid doesn't work for a few minutes. That is probably a bigger problem. In IoT, there are lots and lots of challenges. And industrial IoT, even more. Number one, in general, is the security. People say, and this is also, in agreement with analysts, it's not a matter of if there will be a security breach, a massive security breach that will cause literally death of people because of that. It's when. And that is unfortunately something that we might expect because bad things happen, errors, mistakes, software bugs, etc. And that is probably something that is going to happen in the future. We hope not, but we should expect it. But that's only one aspect. So the security is a key issue. When everything is connected, then everything is also more like kind of open to security breaches. Another important aspect is the lack of standardization. Everything out now there in IoT and industrial IoT has its own version and standard and protocols. There are hundreds, if not thousands. And that is a huge problem because things are completely incompatible. You need to program to use an API from here and a library from there to connect things. And that is fine, but it is always something that stops of course, the adoption and the creation of new projects. And then there are all sorts of other things that I'm not going through all of them, but you can read them, or maybe you have already read this list. We all know what cloud computing, or what a cloud is, I guess, right? If you don't know it, well, I think you should just check on Wikipedia. But there is actually an interesting new way to provide infrastructures, and it's called fog computing. So cloud, of course, means something up there in data centers where you can spin up like new servers whenever you need them, whether they are virtual or virtualized or not. But OK, they're all controlled. In the Internet of Things, there is another layer, usually, which is down here, close to where things are, and that is called the edge. The edge is where you have things that must be controlled, or you are monitoring, or you are actually configuring and managing. There is also a set of layers in between. And how do you call these layers? They are usually gateways, routers, but in general, they are now called the fog. They are something where you have an environment with multiple layers. And these layers are really important because in every layer, you have some computing and storage that is necessary. So if you think about like the concept of client-server in the past, where you had the client and the server, and now you have multiple layers and you have cloud computing, etc., the idea of fog computing is very similar. Things are really much more complicated today, but unfortunately, they must be like that. Otherwise, we will have just too much of a huge environment down here and very small systems that are hard to reach up there. Just to give you an example, think about things that are happening in your car. This is where your car is. And things that are happening in a cloud server up there. And when your car is passing information to the cloud, it's absolutely fine, and maybe you don't need to pass this information all the time. If you have an interruption of this connectivity or communication, that is fine. But what if you must receive something very important from the cloud down to your car? That is where cloud computing doesn't work. If you have a layer in between, like, for example, small systems that are on a motorway or on the road that can give you more information in between, that is the concept of fog computing. the fact that you have computation and storage at multiple layers, not only in the cloud and down at the edge. There are, and I'm skipping now this very quickly, but there are what we call 8 pillars of fog computing. These are defined by a consortium called Open Fog Consortium, which is a consortium under the umbrella of the IEEE organization. And they have referred that the pillars as something that, if you are familiar with cloud computing, is very, very similar. But again, all these things go from large data center down to the smallest possible things that you may imagine. Now that we have said a little bit of the base of what we have in Internet of Things architecture, let me introduce you to something that we have created as an open source project just to, let's say, implement this idea of the fog architecture in real life. We created a project called FogLAMP. Well, fog, of course, that is pretty clear, related to fog computing. That is specifically something related to the 8 pillars that you've seen before and that structure that I showed you, the multi-layer structure. It's a platform for Internet of Things and a component of fog computing. Now, the concept of FogLAMP is, of course, it resounds the fog on one side, lamp as you wish. It can be a lamp, meaning something that can have light in the fog, or lamp like the lamp stack. It's up to you. We like to make it just based on your on what you like, what you prefer. The main thing to remember here is that it's a modular microservices architecture. And here, when we talk about microservices, we don't just refer to microservices that can be spinned up again in the cloud, but in a very, very real concept of microservices, meaning services that can be distributed on multiple systems. They can be real microservices as, let's say, strictly speaking, like kind of Linux processes that run somewhere, or they can go down to nano services. Because unfortunately or fortunately, when you install a service on things like this, you don't have Linux running here, but you may have maybe a thread that can run on one of the processors of the smart boards that you have in here. And in that board, you can have a service as well. It could be what we call the nano service, if you like these names. But just in general, you may have a part of the code that is integrated into this distributed environment. You can make it in the cloud, so you can install it in the cloud on small systems, and it can also be highly available, or it can run in standalone mode. That's up to you. The idea is to have this platform that runs on multiple systems. So I have here just a bunch of stuff, but there is a version that is running, for example, in one of the virtual machines or in AWS, or I have also something running on Raspberry Pis. I don't know if you ever played with Raspberry Pis before. So this is a Raspberry Pi 3. We have down here a Raspberry Pi Zero, which is a ½ gigabyte ARM chip, and the cost is what they call it, the cost of a latte. So basically something around €5 or less, probably here in Spain and in Italy. Well, actually, the real board is way smaller. It's just this one. This is only an extra set of sensors that we have connected to it. So the sensors, of course, are used to collect data and different information. So FogLAMP can run here, or it can run, for example, in smart devices like smart gateways. You can have it into like a typical Dell or Cisco gateway, or other devices on Netgear, for example, usually with embedded Linux. That doesn't need to be only on embedded Linux, or it can run in the cloud in one of the maybe an instances you can spin up in Google Cloud or Amazon or Azure. It's fully open source. It's under Apache 2 license. And the reason is obvious and simple. We want massive adoption. We don't mind about the fact that everybody can take it now and even install it into closed source. That's absolutely fine. We are super happy if you do that. So if you have if somebody has in mind maybe to build something even commercial, we prefer not to, but sometimes it's necessary, and so you can use this platform. It's written partly in C, C++, and partly in Python, and we are moving as much as possible to C now. So let's say that the modules in Python have been more of a kind of a first prototyping. They work, but of course they are much slower, and they have lots of other problems that if you are a Python developer you may know on a server side. But that's what we have today, and it's still reasonably okay. And then we have, of course, it is available on a large number of platforms. And when I say on a large number, is our development environment is based on Ubuntu, on Debian platforms, but we deploy it on Intel platform for Cortex chipsets, which is the Raspberry Pis, but also on Cortex-M. Cortex-M is another processor where it runs with a different environment. ARM provides something called Embed OS, which is an operating environment very different. I mean, don't expect something like Linux. It is literally the firmware that is used to interact with the chipset, but the resources that you can address are relatively limited, and is not really like a typical operating system you're used to if you work with IT like in information technology. And of course, it's on GitHub. So if you are interested, you can go and check the project. That's the URL, but it's easy to find clearly. The architecture, as we said, is a multi-service, is a microservice architecture. So here, let's see what we have. The blue boxes here are the services that you can start. So there is a core, and inside the core we have some modules that are related to the multi-tenancy, the high availability, the federation of the data you connect, scheduling, provisioning. Clearly, the provisioning is to have different modules that can be created and used, and the scheduling is to start or stop elements, etc. There is a storage layer that is based on a typical database, but it can be also just memory. For example, if you install everything on a tiny thing, there is no, maybe sometimes not real storage there, so you just use an in-memory structure. And then we have plugins that we call north and south plugins. So you may wonder still, okay, but what is this thing? I mean, how does it work? How can I use it? The idea is, here you have things that are running, are working, like, let's say, for example, the control for this room, like in terms of lights. There are smart buildings that can maybe make the glass darker because the sun is coming, or the air conditioning, or I don't know, maybe some fire detectors, etc. So you can have control from what is called the south plugin here. And the south is in the typical idea of networking, something that goes down to the things, so the smallest part here. North, you have the cloud. You have systems that are collecting more and more information. So if you have thousands of sensors that are available on multiple rooms, like again, multiple air conditioning systems, fire detectors, etc. All these connectors provide data. Data is buffered here, and then, if needed, all of it or part of it goes up north to maybe a bigger system where you can do analysis. You can do like remote and bigger analysis. And if you need this information locally, you can use it through a REST API. So you may have again, for example, for this building, the information coming from the South plugin stored here, and you can check it here. And perhaps you can send up the data to cloud systems and other systems can analyze the overall information. All the green things you see here are modules that can be plugged and unplugged. So you can add a new one here or remove them if you need like to connect different stuff. Now, what we have today is, of course, limited, considering that we are just at the very beginning of this project. So we haven't completed everything. You see that the core is now almost empty. Well, actually, there are some security aspects, of course, we take care of. There is a management API. We have a scheduling system to control the environment. And right now, we have a storage layer that is based by default on SQLite. We have Postgres as optional. It's actually fully functional, but Postgres is a big no-no if you use, for example, an SD card. You immediately, you can easily burn it in like, I wouldn't say a week, but it depends on how much you start writing data on that. So it's, again, it depends. If you have like a larger environment with a proper disk, then Postgres is probably a good idea. And again, if you run FogLAMP on this Raspberry Pi, it has ½ gigabyte of RAM, and everything should run here. So Postgres is probably not the best idea. If you run it on 1 gigabyte with this one, then yeah, it fits pretty well. Down here, we have a few sensors or protocols that we understand. So if you are sending data through HTTP, that's easy. And that means also that we can capture data from other internet services. CoAP is a protocol for constrained devices. It's used and appreciated usually in the IoT world because if you have like low power consumption systems, things that work literally with the tiny batteries, like the typical watch batteries, you want to use CoAP to reduce very, very much the power consumption. We also have HTTPS, of course, and there is a way to use CoAP also in a secured way. And then we have other sensors, like, for example, this DHT11. Again, maybe you never heard of it, but these are small things, the cost of like 50 cents or $1. And this is a HT stands for humidity and temperature. So the DHT11 is a tiny sensor that you can buy online, and you can directly connect it to a Raspberry Pi or other devices, and you start collecting information, data on temperatures, etc. This is from TI, from Texas Instruments, and is a set of sensors. You still have also a gyroscope, a barometer, and other sensors. There are 12 in total. And again, it's connected through Bluetooth with this one, BLE sensor tag. Actually, this thing is called sensor tag, and it works as well. And then we have other things, like EnviroPath is another sensor. PT100 is an industrial temperature sensor that we use with some rooms that have specific needs to control temperature, etc. How can you use? Yeah, sure.
You just mentioned Bluetooth.
Yeah.
I wanted to ask how integrated is Bluetooth appliances with this architecture? How can you make them part of the architecture, or they are just additions that need to be
right.
modified? Yeah.
It's a great question because so the architecture is absolutely open, and actually the key parts are the ones in blue. The way you integrate Bluetooth is through this green part. So it is as open as you want. You may use Bluetooth, or for example, up north you may use LoRaWAN. to connect with other systems and start sending data using other mechanisms. So what I'm saying is, provided that you have libraries for your environment that you can connect through C or Python modules, you may use it. And for example, with BLE, with the Bluetooth environment here, we just use the standard Gantt tools that are available on Linux, which is not the best way, absolutely. It's a prototype, it's something that shows you how you can use it, but it is really available for everybody. So you can just do with Debian an apt install of the Gantt tools, and you have available what you need to connect the sensor tags through Bluetooth.
So probably I should have asked a different question. I mean, once you connect something through Bluetooth,
yeah,
is the whole system aware of that Bluetooth appliance?
The whole system, meaning this one?
Yes.
Yeah, you must set some configuration. With this version, the configuration is manual now, meaning that you have to say, okay, I have this particular device and it's called BLE001 or whatever. We are working on the next version that has lots of auto-discovery systems. So the idea is that you start, for example, FogLAMP. You have like a bunch of sensors that as soon as they come up, they are automatically identified and recognized. And it's not an easy thing to do, but we are working on that. And the idea is to have it ready in about, for the next version, proper version 2.0, which is in about 6 months. Right. So how do you consume this? How do you use it? Well, first of all, everything is on GitHub. If you go to the FogLAMP main organization, you will see all the projects. I'm going to talk about that in a minute. But if you check within that organization, there is a FogLAMP repo with the upper F and all uppercase lamp. That basically contains everything you see here. Actually, we are moving some stuff, so you will see maybe less of this, like the EnviroPath, for example, is now on a separate repository, etc. But other than this, you can actually take a Debian package and you can install it on your Raspberry Pi or on an Intel box or VM if you want. We have different projects and repositories you can find. For example, there is a FogLAMP GUI. So through the REST API, you can consume the REST API and see things graphically through the GUI. What we call FogLAMP-south-something is basically this set of plugins. So what do? You simply update your environment, and in the next version, it will be through a command that comes through the GUI, or you can instruct it via the REST API with an orchestration system. And the system will be available to collect the information. So for example, to Giuseppe's question regarding the Bluetooth, if I have a new sensor or a new Bluetooth system, I can have everything already pre-configured and also secured in a way where I can install the plugin, and FogLAMP will immediately recognize what is available. So these are just the name that you can find online on GitHub of the repositories that are available. And then there are a few other examples, like the South Weather is just a small thing that is used to collect data, weather data, that you can then take, load into the storage layer, and, for example, use for some analysis with your temperature sensors. You may collect data. This one is quite interesting. The Wemos DHT22 is this thing. So here we have a small board called Wemos, and again, the cost is like a couple of euros. We install a tiny part of this architecture, which basically is used to create a JSON payload of the information that is collected by this sensor. The final result is that we take the data in the right payload, and the data is ready to be used inside FogLAMP or sent up north. And again, sent up north means that you can use it for more detailed analysis in one of the systems that are used for that. It could be, I don't know, it could go into in a Hadoop system or on MySQL, on Oracle, you name it. It doesn't really matter. It doesn't, from a FogLAMP point of view. So that's what I showed you already. This software runs already on multiple systems. I showed you the Raspberry Pi 3, the Zero. These are gateways, like a Cisco router. This is a typical Cisco 829. One of the projects that we have has this Cisco router on top of tracks that go down into a mine, literally, in Colorado. They basically go down to this mine and they capture data. So they have data that is sent to the sensor, is stored into the storage layer in here from all the sensors that they have into the tunnels. But the data is not sent up because there is no internet connectivity down there. As soon as the trap comes up with everything that is carrying, but also with this router, it can start sending data to a cloud system. So the Cisco router is used to collect information, of course, but also to store it into FogLAMP and then send this data for further analysis to the other systems. And then we have that one up there is an Embed OS board. This one is a Toshiba box. It's a 2U box called Flash Matrix. It's a huge thing, meaning that it has something like up to 24 terabytes of SSDs or flash disks on this, and it's used for like machine learning at the edge. That's what they call it. And in here we have just a simple, tiny Docker container that runs FogLAMP, and it works to provide the data to the algorithms that are running here with Spark, and then send the data again up north. I already mentioned the REST API, which is basically used for the user interface. Let's see some of the use cases. How are we going? Okay. Some of the use cases, for example, in a factory. There is a factory plant, for example, where you have your machinery that is working, it's executing something. FogLAMP is usually, it's used for collecting the data, the monitoring data. IoT platforms are usually divided in two areas. On one side, you have the typical control, meaning that your platform is used to control systems. And on the other side, you have the data collection and monitoring. So FogLAMP is on this second type, to collect the data and monitor it. You can add an application, for example, here, using the REST API, maybe not through the UI, but directly. You can add an application that consumes this data, but then the control is really, it's part of this application, it's not part of FogLAMP. In here, the idea is that applications can be even more connected as a microservice for FogLAMP, but we are not there yet. As you can see from the architecture to the implementation, we don't have this module yet. We have designed it, so the FogLAMP architecture is designed to handle it, but we don't have it yet. So we have systems that are on the floor plant, connected to machineries and other stuff, collecting the data, and then using the data directly into this floor plant, or sending the data up to the headquarters, or maybe into cloud systems or third-party systems. And again, this is all through FogLAMP. So the North plugin takes care of the connectivity. Because okay, think a little bit like Kafka. I mean, where you start messaging this information and then handling the fact that this information will be securely sent somewhere in another system. Why shouldn't we use Kafka? We can, of course, and it can be absolutely used. But again, don't forget that the idea is that this software must run on very, very small things, and it must consume very, very little energy. That is the problem, the main problem. So we can't use something like Kafka. Java, at the moment, it will be different in probably a year or two, but it's a no-go. It's not something you can use now. Another important aspect is the fact that if you think about FogLAMP and you think, okay, why can't I just use a database with a little bit of elements? And that's another interesting point. But the difference with a database and a data management application is that usually in a database you have data at rest. The data is there, is stored there, you insert data or you extract data, you read it. That is the main objective. In an environment like IoT, data is at rest somewhere and in motion, is usually moving. So the other element that is really important is that you don't know where your data is, and you don't know if the data, or you may not know where your data is, if that data must be part of some analysis that you are doing. So you may have information that are important for you to be analyzed, and they may still be at the plant, or they may already be at the headquarters or somewhere. And that is, again, another important aspect. And with FogLAMP, that's what you can do. You can basically raise a query that can go and be executed on all the elements and identify some of the records, for example, that are necessary for your analysis. Here is another example. This was actually presented for another event that we had with MySQL in Dublin. So, of course, we had the plant of Dublin, and these are the lorries for the Guinness, of course, sending beer everywhere. And having FogLAMP running on every lorry and collecting information, for example, of the status of the vehicle and also, for example, the geolocation, etc. And that can go up to the main headquarters and perhaps also instructing, sending back information like, hey, you should move these things and you should maybe change route, etc. Again, I'm like predicting another question. Well, I can do this today already. So why do you need FogLAMP? And the objective is, okay, today you can do it. It's a special project. You may use some libraries, but you don't have a platform. You don't have something that you can use to quickly deploy this project. And the idea is to really speed up the deployment of this project. You may have seen already this logo. This is the logo of one of our, or let's say our main investor. It's a company called OSIsoft. They have a time series database called Pi. That's why there is a Pi, of course, logo there, which is a very, very old, I mean, it's a 30 plus years old technology, but it's used pretty much everywhere. Like all the power, almost I would say 90% of the power grids in the world, they use Pi. Oil and gas systems, chemical factories, they all use the Pi servers. So maybe in the IT world, they are not well known, but in the industrial world, they are absolutely everywhere. And they basically invested in us to build this platform to connect all these systems to their historians. But we are not only for Pi, clearly. Okay. Smart roads is another example. Am I doing, I mean, Okay, I still have a few minutes, I guess, I hope, right?
You are 3 minutes in too long already.
Already? Oh, no. Okay, sorry. All right. Okay, let me skip the demo, but if you are interested, we can do it. And what we are going to do is to add more and more plugins. The other important point is that behind us, there are other technologies and other companies like ARM, Toshiba, Sprint in the US. They're all working together to make FogLAMP even bigger and more important for them. And so, if you have any, we don't have time for questions clearly, but if you're interested, I will be here all day today and tomorrow, and probably also in the coffee area. So if you need me, please just reach me, and I'll be happy to answer your questions. Okay? Thank you.